Hi everyone, this is Mrs. Jackson. This is Chapter 3, Section 6, Part 2. In this video, we are continuing to talk about the graphs of polynomial functions, and specifically, we are going to talk about a concept called end behavior. So the key concept here, we use this phrase, end behavior, to describe what does the graph look like on the left side and the right side of the graph. In other words, how is it trending when our domain is approaching positive infinity, really big numbers, and negative infinity, really small numbers? And so we're really looking to describe, is the graph trending up or is it trending down on the left and the right side of the graph? That's what we call end behavior. And as it turns out, that end behavior is dominated by the function's degree. As we know, that's the largest exponent, as well as the sign of the leading coefficient. So is it positive or negative number in that first term? So let's take a look at an example here of a polynomial function. It is in standard form. We have descending order of exponents, so we're all set there. And if we think about it, the output value y is really going to be dominated by this first term. So in other words, if we put in a big number in there for x, a big number raised to the power of 5 is going to be a really big number. And even though we're subtracting something here, because this is a smaller exponent, this is still going to dominate the value of the output. So that first term is really what we're going to be focusing in on when we think about how the output's trending. Also, we are really going to be looking at the effects of that degree here, whether it's even or odd, is going to have a lot to do with what's going to happen with the output, and the sign here of the leading coefficient. So I'll say sign. I'm going to abbreviate LC for leading coefficient. In this case, it's positive, and our degree is odd. So we're going to be observing the effects of different combinations of even and odd degrees and positive and negative leading coefficients. So let's take a look at example 1 and see what's happening here. So I have a polynomial function. The degree is 6, and the leading coefficient is positive 2. So we can say that our degree is even, and our leading coefficient is positive. So let me introduce you to some notation here. This x with an arrow pointing to infinity, that in English is basically saying as x approaches infinity. So when x is approaching positive infinity, that's the right side of the graph. And so if we go ahead and imagine a really big number, think of 100 or 1,000 going in here for our value of x, we only need to focus here on that first term. So if I put in a big number in there for x and I raise it to a power of 6, which is quite a big power, that is going to grow even bigger, very, very large number. And if I multiply that by a positive 2, then my output, y, is just going to get really big. So y is also going to approach positive infinity. In other words, our y on the right side is going up. It's growing. Now, what if I put in a negative number, a really very small number, like negative 100, negative 1,000? What's going to happen there is if I substitute in that negative number in here, the even power, the even exponent, is still going to make that output positive. And when I take a positive number and multiply it by another positive, then I'm still getting out a positive. So our output is still going up. It's going to trend towards positive infinity. So if we were to summarize that, we've got an even degree, and we have a positive leading coefficient. And what's happening there in the graph is we're going up on the left and we're going up on the right. And so just to kind of give you some kind of visual, imagine some kind of curve that's kind of maybe going up and down, you know, whatever. But on the left-hand side and the right side of that curve, it's trending up. Now let's take a look at what will happen if that leading coefficient is now negative. So this time we have a -2, and so we're going to keep with the same degree, an even degree of 6. This time our leading coefficient is negative. Let's see what will happen. If I put in a big number in here, trending towards positive infinity for x, and I raise it to a power of 6, that's growing all the more larger, very large number. If I multiply that large positive number times a negative number, then that output is going to go negative. So our y is going to approach negative infinity. In other words, it's going down. And again, this is on the right side of the graph. On the left side of the graph, and I guess I should have written left over here as well. So on the left side of the graph, when our domain is going way negative to the left, if I put in a big negative number in here for x, it's being raised to an even power. That's going to turn that number still positive. When I take that positive number and multiply it by a negative coefficient, then I'm going to end up going negative. So our output is going to trend again down. So if we summarize that, we have an even degree. In this time, we have a negative leading coefficient. We're going to end up with down on the left and down on the right. So give a little quick visual, maybe draw a little graph here. Maybe we've got something like this, and both the left and the right side are pointing down, trending down. All right, let's take a look at what would happen if we have an odd leading coefficient. So this time we've got a leading term, 2x raised to the 5th power. So our leading coefficient is positive and our degree is odd this time. What will happen? Well, as x is approaching a big number, in other words, on the right side of the graph, if I put in a big number in here for my x value, raise it to the power of 5, that's going to grow very big, multiply it by a positive number, we're going to be trending up positive. And on the left side of the graph, if I substitute in a very small number like -100, -1000, substitute that in, this time with an odd exponent, that result is going to stay negative. And if I multiply that by a positive leading coefficient, then my output is negative. So our output is going to trend down. So if we kind of summarize that, we have an odd degree, and we have a positive leading coefficient. Our graph is going to be up on the right and down on the left. So if we take a look at, just maybe draw an example curve, think of something down here, kind of going up to the right and down on the left. And our last combination here example 4, if we have a odd degree and a leading coefficient that is negative, and we put in or substitute in a big number to the right here, a positive number in here for x. If I raise that to a degree of 5, it grows bigger and bigger, positive. Multiply that by a negative coefficient, and our output is going to be trending negative, down. And again, that's on the right side. And when we take a look at the left side, if we substitute in a very small number here, a negative number, negative 100, negative 1000, raise it to an odd power, the result is negative. If I multiply that negative by a negative 2, then we get negative times a negative or a positive, so our output is going to trend up. Positive number. So we've got an odd degree, and we have a negative leading coefficient. That is going to result in up on the left and down on the right. Draw some kind of quick little curve here. Something like that. And so the end result is that just looking at the degree, whether it be even or odd, and the leading coefficient, whether it be positive or negative, can tell us an awful lot about what that function graph is going to look like. Hope this video helps. Thanks for listening.